Minus 4 times A, which is 3, times C, which is 5. That would be 25. Did I mess something up? Why do I feel like that's too big of a number? Oh, no, it's fine. It's fine. Never mind. I was thinking of a different problem. All right, so that's going to be 25 minus 60. For some reason, I thought this was the one that had 2 answers. I'm like, that's not right. I don't have the right answer up there. But that's going to be a negative 35. It is a negative. What are you looking for? She said she was going on vacation today, that she was leaving this morning.
It's nice of the parents.
It is nice when they let you know.
Sorry.
That's okay. All right, so it's a negative number, so it's going to be no real solutions. Just for future ideas, we know it does have 2 imaginary solutions, though. All right, our next one is not ready to be put into the quadratic formula. It is not set equal to 0, so you must subtract 4 from both sides. So we'll have 2x squared minus 3x. That'd be minus 2 equals 0. A little hint. If your A or your C is ever negative, not both of them, but if either of them are negative, it's almost always going to be 2 solutions because you're subtracting 4AC. So if either one of them are negative, it turns into adding. So that's what's going to happen on this one. So we're going to have B squared, which is negative 3 squared, which is a positive. Then we are going to subtract 4 times A times C. And note those 2 negatives. That means I'm going to have 9 plus something. That's going to be a positive, and it turns out to be a positive 25. So it's going to have 2 real solutions. All right, questions from the homework? Hope. 79. Ooh, that's not our homework. It's tomorrow's homework. 79. 79 says, use the method of your choice to find all real solutions to the equation. So the problem with that one is we're taking a square root of a square root, right? So we have, when we reduce this down, we're going to have x squared equals the square root of 2. And we take the square root of both sides, and it looks something like this. X equals the square root of 2. But we never, ever write it like that. We never write a square root of a square root, unless it would be square root of something like this. You could write like that, plus 1, then you leave it like that. But we're just doing a square root of 2. Let's talk about what's happening here. All right, square root of 2 we can rewrite as 2 to the 1/2. That is the same thing. A fractional power means you're taking a square root or a cube root or a 4th root, 5th root, whatever you would have you. So if we look at that square root of 2, that is realistically taking 2 to the 1/2 to the 1/2 power, which is going to actually equal, you multiply exponents to exponents, which would be 2 to the 1/4, which you could further write as 4th root 2. Either one of these 2 is actually the solution to that problem. You're not going to plug in your calculator. You're going to write it as is, just like you'd write the square root of 2. You're going to write a 4th root 2. Is that jogging some memories of Algebra 2? All right, other questions? Yeah? 55. All right, so we have 4x squared minus 8x plus 7. Well, real quick, if I did a times c, we would have 28. Yeah. Oh, I'm just looking if we can factor it.
Oh.
Or does it say we have to use the quadratic formula? Is that in the section that said you had to use quadratic formula?
Yeah.
Oh, okay. Then we have to use the quadratic formula. Ugh. I'm pretty sure that one's factorable, though, so blah on that. All right, so we would have 4x squared minus 8x plus 7 equals 0. Quadratic formula says we're going to do negative b, so that's going to actually be a positive 8 out front. plus or minus the square root of 8 squared minus 4 AC all over 2A. That'd be 2 times 4. Let's just quickly calculatorify this. So that'd be 64 minus 4 times 4 times 7. So you should have got, oof. Did I have the wrong answer on that one? I don't know. What'd you end up getting?
I ended up getting, well, I mean, for a final answer, I got 2 plus or minus I times the square root of 3.
Yeah. And I had -1/2 and 3 on that one, right?
Yeah, I think so.
Yeah, that is definitely a wrong answer because that should have a negative, because 8 squared is 64. It should be -48 under there. Yes, okay. Correct. So you did find that mistake. So you'll get the point for that. So this is -48 all over 8, which we could go further and say, well, that's 8 plus or minus, should I simplify? Yeah, so we'd have, 4i times the square root of 3, because 16 goes into it 3 times. Yep, that's right, divided by 8. You could go one step further and go boom, boom. So our correct answer for that one should have been 1 plus or minus 1/2 I square root of 3 would have been the correct answer for that one. Is that what you ended up getting?
Yeah.
Okay, yep, that is correct.
Not after this problem. Couldn't get the graphs to work.
Couldn't get the graphs to work?
That might be something on my calculator.
What didn't work about them, I guess?
I don't know.
Which one?
For 71 and 75, said we needed.
Oh, both of them?
Yeah.
Let me type in 71. I want to make sure it's not like a really hard. X squared minus 8.4 x plus 12.25. Graph that bad boy. Yeah, 71, if you just hit zoom standard, you should see it.
So do I...
It would just have one real solution. If you just hit zoom standard on that one, if you type it in. We can work on that later. I don't want to sit here and...
Yeah.
But they both work. All right, other questions? Because we could talk about that. Yeah. 89. So 89, you had to use your cross multiplication. So let's just take a picture of that one. So 89, we had to use cross multiplication to simplify first. So I did my x minus 12 times that x plus 7. Then I did my 3 minus x times that x plus 4, which is over here. Do you have a specific step that you get stuck on?
No,
just so I can focus on...
I don't know, I was going to try to factor it out.
Oh, okay.
Yeah, I didn't know.
Kind of an easy way to factor, if you ever get stuck, is just take your first term, which is x in this case, and multiply it by both of those. So let's kind of do that up.
I mean, instead of cross multiplying, factor out.
Oh, I gotcha.
Yeah, I don't know.
So you could multiply by the lowest common denominator, which would be 3 minus x times x plus 7, but you would have resulted in the exact same thing. Fractionally equaling a fraction, we can either just use cross multiplication, or if you were looking for a lowest common denominator in this case, it'd be 3 minus x times x plus 7, which when you distribute this, you'd be left with the x plus 7 on this side, which is here, and you'd be left with the 3 minus x over here. So either method should result in the same thing. Cross multiplication is probably the best when it's a fraction equaling a fraction, or the means extremes. Did you try to graph it again?
Yeah, no, you keep on getting errors.
Oh, you get errors popping. Okay, that means I need to look at your calculator.
Yeah.
Yeah, okay. Other questions, though? Yeah. I don't think we did. So that would be b squared, which would be 6 squared. I'm sorry. I'm inside. We're looking for the whole answers, right? We're not looking for how many. Yeah. All right, so we're going to have negative b. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Oh, okay. Yeah. Yeah, because we're going to have 0 inside of here, right? And then we're just going to have negative 6 over 18, which is negative 1/3. All right. Other questions? Okay, then let's get to the hardest lesson of the quadratic portion, in my mind, because they are word problems, and everyone loves word problems. Right? Right? Sure. There we go. All right. So we're going to start with the distance problem. I didn't give a lot of space because there's not a lot of work. There is a lot of work in this one. And it's primarily because when we start solving it, we're going to realize it's a quadratic, and then we have to find a way to solve it using quadratics, which means we're using factoring, we're using the quadratic formula, we're using complete the square, or you're going to use one of those methods. All right, so let's read this. So it took Daniel 30 minutes longer to drive 275 miles on I-70 west of Green River, Utah, than it took him to drive 300 miles east of Green River. Because of a sandstorm and a load of full cantaloupes, ooh, mathematicians love cantaloupes for some reason, he averaged 10 miles per hour less while traveling west of Green River. What was his average speed going east? All right, we know it's a distance problem. We know it's a distance problem. I usually put distance on the right, but for this one, I'm going to actually put it on the left-hand side. So it doesn't matter. It really doesn't. But I'll talk about why I'd put it on this side. So I have distance equals rate times time. All right, we're going two directions. We're going west, and we are going east. So it says it took Daniel 30 minutes longer to drive 275 miles on I-70 west, and then later he's driving east. So we're going to have a west direction and an east direction. Now, why I put distance first is because they actually give you both the distances. It says his west direction was 275 miles. So I'm going to put 275 here. Then it said going east, he was 300 miles. So we put 300 here. So I'm going to put the distance all by itself because I know I'm not really using it. I know I'm not putting x's in here or anything because I actually have these values down. I have 275, I have 300, so I kind of get it out of the way. All right, then it says that it took Daniel 30 minutes longer to drive 275 miles, so his times are different. Then it took him to drive 300 miles east because of a sandstorm and a full load of cantaloupe. He averaged 10 miles per hour less while traveling west of Green River. So we have two ways to set this one up. We have two ways. We know two different things. We know it took him 30 minutes longer to drive west, and we also know that it took him 10 miles per hour less to travel west. So the two ways we could set this up. We could go on this first one and go, okay, it took him 30 minutes longer to drive 275 miles, so it took him longer west. So that means I'd go, don't write this down yet because I'm going to actually pick the other method. And this would be x plus 30. This would give me that 30 minutes longer. And then we could definitely fill this rate in as being, okay, that would be rate equals distance divided by time. I could go 275 divided by x plus 30. Here I could go, okay, rate equals distance, so this could be 300 over x. That is one way to solve it, and it'll work out just fine. I'm going to go the other way with it. I'm going to talk about the rate. So I'm looking at the rate, and it says that he averaged 10 miles per hour less while traveling west. So he averaged 10 miles per hour less while traveling west. So I just want to have both things being the exact same. So that means if I let my east rate be x, my west rate would be x minus 10. That would make my time, just a reminder that you can always write time equals distance over rate by changing that formula, which would be 275 over x minus 10. And then we can do 300 over x. And the whole reason I picked my rate to be the direction I'm going is because I want to point to these two. It just makes it a little neater for your notes. These are our two important values right now. Are the times between them equal? So I'm looking at these two. Would it be true if I set this up like this? 275 over x minus 10 equals 300 over x. Did it say that the two times are equal? No. No, it doesn't. Hopefully you can read the part that says that the times are not equal. It directly says the times are not equal. It says right here, it took Daniel 30 minutes longer to drive west. It took him 30 minutes longer to drive west. It took him 30 minutes longer to drive west. So these cannot be equal. This is not true. That is not true. And that is because it took him 30 minutes longer to drive west. Now think about this. Does that mean to make them even, would I add the 30 minutes to the west side of that equation, or would I do it to the east side of the equation? Which side would I add the 30 minutes to? Got a 50-50 shot, yeah. I would add it to the east side. I would add it to the east side because this is the longer trip. If this took 60 minutes, this took 30 minutes. The only way to balance it would be to add it to the quicker time. So I need to add 30 minutes to the right-hand side. Now, note we are in time. So we're probably not going to put 30 minutes. We're probably going to put 1/2 for 1/2 hour because we're going to talk about rates in miles per hour. So we're going to turn that into 1/2. So this is our longer. So we're going to add 30 minutes here. So our end equation is going to be 275 divided by x minus 10 is going to equal 300 over x plus 1/2 because we want it to be in miles per hour. I'm going to go ahead and slide this over so I have a little bit more room. I'm going to slide that guy right under here. Uh-oh. With a whole bunch of crap with it. I'm just going to rewrite it under there so I don't move a whole bunch of crap with it. In fact, I'm going to go to the next slide. I'm going to go to the next slide so I have plenty of room to finish everything. Let's copy that. Let's go to our next slide so I have all the room to finish this. Okay. But we just need to solve this equation. That's it. We need to solve for x. And the reason why it's in this section is because when we solve for x, we're going to find out it's a quadratic equation. Because to get rid of the fractions, we're going to multiply both sides by our lowest common denominator. In fact, this would just be our common denominator because I don't know for 100% fact that it's the lowest, but we still, for whatever reason, call it the LCD. Our LCD is where you multiply all of your denominators. So we're going to have 2 times x plus, x minus 10. And we're going to multiply that on both sides. So I'm going to distribute this to everything. Now let's speed this up a little bit. When I multiply this entire thing by this one, your x minus 10s will cancel off. So you'll be just left with that 2x. So we're left with the 275 times just that 2x remains. Then the other side, when we multiply by that 300 over x, our x's would cancel out. So I'm just left with that 2 times x minus 10. So we're going to have 300 times 2 times x minus 10. Finally, when I multiply by that 1/2, your 2's will cancel out, and we'll just be left with that x times x minus 10. You can see where that x squared is going to come from that x squared minus 10. So let's go ahead and simplify this. So we're going to have 275, so that's going to be 500 plus 50, so that's going to be 550x equals, well, think about this, it'd be 300 times 2 times x, which would be 600x. Then we have 300 times 2 times that 10, or that negative 10, so we're going to have negative 6,000. Then we're going to have plus x squared minus 10x. Now we have that x squared, so we're going to get all of our x's probably on the right-hand side so I can keep it positive. So I'm going to keep everything to this right-hand side so I can have this x squared being positive. So we're going to subtract 550x from both sides. So we're going to have 0 equals, I'm going to move the x squared out front. Then we're going to have plus 50, I almost forgot about this guy. So we have that 600x and that negative 10x and that 550x. So 600x minus 550x would be 50x minus 10x would give me 40x. Then we'd have minus 6,000. Let's think about this right now. I'm sitting with x squared plus 40x minus 6,000. What would be the easiest way to solve this one? I would accept 2 correct answers and 1 kind of incorrect answer. Yeah, Brian. 400? Yeah. Yeah. So complete the square would be pretty easy, right? Because I don't need to divide anything. So let's go ahead and complete the square. What would also work is, did you have, yeah?
I think by factoring.
Factoring would also work because you'd have, your a times c would be 6,040, and you can actually come up with the negative 60, and 100 would work for that one. So factoring or completing the square would work on this one. Brian, I would gear it towards completing the square because 6,000 is sometimes hard to see, your multiples. Otherwise, you're spending a whole bunch of time plugging stuff in. So let's go ahead and complete the square. Let's go ahead and complete the square and see how well that works. So I'm going to write it as, so I'm going to flip everything. So I'm going to have x squared plus 40x plus something, not plus or minus, but plus something is going to equal, now it adds 6,000 to both sides, so we're going to have 6,000 plus that same something. And that something is just b divided by 2 squared. And this one would be b divided by 2 squared. All right, well, when I complete the square, we're going to have x plus 40 divided by 2 is 20 squared, is going to equal, well, just like Brian said, 40 divided by 2 is 20. 20 squared is 400. So we're going to have 6,400. 6,400 is a nice number because it looks like it's going to be a perfect square. It's like 64. So we're going to take the square root of both sides. And we're going to have x plus 20 equals plus or minus. And what's the square root of 6,400? I gave you a hint with the 64. I gave it too nice. 80. This is plus or minus 80. All right. Then we're going to subtract 20 from both sides. X equals negative 20 plus or minus 80. that leads us to two possibilities. Either we're adding 80 or subtracting 80. Negative 20 plus 80 equals 60. Negative 20 minus 80 is going to be negative 100. Let's go back and look at what our x meant. Our x meant, what is the rate going east? Would it make sense if our rate was negative 100 miles an hour? Maybe it's going backwards really fast. But no, it's not going to make sense to do that negative 100. So that's going to get out. We just look at that x equals 60. We said x was what I was looking for, so it's 60 miles per hour. So this was almost identical to the problems we did in all those word problems. The only difference was, while solving it, it turns into a quadratic. So it requires us to do one extra step. Brian, I do prefer completing the square on this one because this one's 1, this is a big number, but factoring would definitely work if you could see that the 6,000 broke apart. My advice to you, if you're factoring something, don't waste 5 minutes thinking you can factor it and checking a whole bunch of stuff. At that stage, you could have been done completing the square. So just, if you see it, awesome. If not, move on to your completing the square. If this is anything besides 1, completing the square might not be your best option because then you'll have those weird fractions where you have like 2 over 3 over 2. All right, questions on this problem? Okay. Then we're going to go on to some tennis action. So in tennis, a lob can be used to buy time to get into position. The approximate height S in feet for a tennis ball that is hit straight upwards at a velocity v sub 0 feet per second from a height of s sub 0 feet is modeled by this equation. So let's talk about that equation really quick. So in tennis, they say the approximate height. So this is the height of the ball at any given time. At any given time, that is your height. T is going to be your time. So that's your time. Both of them would be your time. So if it's 6 seconds, you'd plug a 6 in for those. V sub 0 is your velocity at which you hit it. And S sub 0 is going to be your starting height. All right, so we'll look at the A, and then we'll go to the figure. A says, use the figure above to estimate the time that it takes a ball to return to the court when it is hit straight upwards with a velocity of 60 feet per second from a height of 5 feet. Why would you be starting at a height of 5 feet? Why wouldn't we start at a height of 0? Hope?
It's the height of the person.
It's the height of the person, where they're hitting the ball, right? It doesn't always have to be the height of the person, but it's where they're actually hitting the ball. They're hitting the ball at 5 feet high. You're never hitting the ball at 0 feet unless you're doing that in-between shot where you're not sure if you dragged it or it hit the ground. All right, so that is the graph over there. Here is our height. At 0 seconds, I'm hitting the ball. I'm hitting the ball, then the ball is going up. So at 2 seconds, it reaches kind of its maximum, and then it comes back down. Well, it says, use the figure above to estimate the time that it takes the ball to return to the court. So looking at that graph, about how long does it take for that ball to return to the court? Nicholas?
4 seconds.
About 4 seconds. I think I did 3.8 because it's not quite at 4. Yeah, I did about 3.8. I did about 3.8 seconds. And that is because of this point right here. That is where your ball is at 0 feet. And it says the time is about 3 seconds, so I went with about 3.8. Now what we're going to do is we're going to prove that. We're going to prove that true by actually solving for that equation. So it says find the time for part A by using the quadratic formula. So we need to complete this equation. This is the height of the ball. This is our height of the ball. This is the equation we're doing. So first of all, let's fill in the stuff we know. Well, we know the velocity. It says that the velocity was 60 feet per second. So our velocity is going to equal 60 in this case. It's saying that the starting height is 5 feet. So our equation is going to be S equals that negative 16t squared plus 60t plus 5. Now, as it sits, you can't solve that equation. We have to bring in, what is the height of ball we're looking for? What is the height of the ball that we're actually looking for? Are we looking for where it's at 2 feet, 3 feet, 5 feet? What is the height of the ball I'm looking for? Yeah. 0. I'm looking for 0 feet. I'm looking for where's the ball hitting the ground. The ground is 0 feet. So I'm looking for where's the ball 0 feet. So I'm looking for where that S equals 0. I'm looking for 0 equals negative 16t squared plus 60t plus 5. If I was looking for where the ball reached 60 feet, I'd put 60 in there. I'm looking for where it hits the ground. That's at 0 feet. Well, that's just a quadratic equation. It isn't factorable. Probably not a good idea to complete the square because you're going to have 60. Well, it's possible because we'd have 60 divided by 16, and we have to do that from both sides. So more often than not, on this one, we're going to use the quadratic formula. The quadratic formula setting that up would be x equals our b negative, so negative 60, plus or minus the square root, b squared, which would be 60 squared, minus 4ac. 4 times a would be negative 16. That's my sign that it probably has 2 solutions. Times 5, all over 2 times a. I'm going to go ahead and let you guys have some time to solve that one. And we'll talk about how to enter in your calculator.
I got 60.6.
I know exactly what you did. This is what you typed in your calculator, probably. Are you using the... I'm thinking you did the negative 60 minus square root of 3920.
No, I just found the square root of 2.
Oh, okay, and just had it as a decimal?
Well, I messed up the first time, so I haven't technically solved this yet, so I don't know if I get it right.
Okay, you don't really have to go much further than this. Because this, we're just going to plug in our calculator to get this value out.
Oh.
Because we know we're rounding, so why go down and simplify it and then put it in our calculator? Why not just plug this in? But if you plug it in as I'm writing it right now, so if you, in your calculator, type negative 60 minus square root of 3,920 and then hit your division button and then put negative 30 in, you would come up with the wrong answer. Because your calculator uses your properties of division, subtraction, your PEMDAS. It would do this division first. You want it to do all of this calculation first, so you'd have to put this entire thing in parentheses. In fact, I'd probably put the negative 30 in parentheses too, just because I overuse parentheses. Overusing parentheses is better than underusing them. Now, if you type that in your calculator right now, if you type in parentheses negative 60 minus square root of 3920, and parentheses, and you divide by negative 30, you should come out with a 3.8. Is it negative? Yes, negative 32. Sorry. Yep. Negative 32. But if you plug that in, you should get out that 3.8. Did that help people that were struggling plugging it in? Yep. Be careful with parentheses. If I have something in my numerator and something in denominator, I always take the time to always put it in parentheses, just to make sure. All right, I did say this is one of the harder homeworks. In fact, this won't be due until Tuesday when you come back. So you'll have the entire class period in class to work on this when you come back on Monday. They are difficult problems, but they all kind of come down to, they turn into quadratic formulas.